Today the topic for discussion is method of false position or Regula-Falsi method. This method is again useful to find the root of transcendental equation and algebraic equations. So similar to bisection method, find first 2 points or numbers a and b such that so first find 2 points or two numbers. Obviously, for convenience, we find two successive integers a and b such that f of a and f of b are of opposite signs. That is, f of a into f of b is less than 0. This is similar to bisection method. And then instead of that bisection formula, that xr is equal to a plus b by 2, we use in this method this formula xr is equal to a f of b minus b f of a divided by f of b minus f of a. R runs from 1, 2, 3, 4, 5. Okay, that is the, if we substitute r is equal to 1, we get the first approximation. Okay, so first find by trial and error method a and b, two numbers successive integers a and b such that, or any two real numbers such that f of a and f of b are of opposite sides. Okay, that is f of a into f of b is less than 0, and then use this formula. And by using this formula, find x1, x2, x3, x4. That is first approximation, second approximation, third approximation. Okay, so first problem on this method, find root of the equation x cube minus 2x minus 5 is equal to 0 between 2 and 2.5. So these numbers are given. These two real numbers, that is the root lies between these two. And if these numbers are not given, then we find these numbers by using trial and error method. Okay, that is this is fx, x cube minus 2x minus 5 is equal to 0 is fx. Okay, so if we substitute a is equal to 2, okay, that is if you find the value of f of 2, then that is substitute x is equal to 2, then we have -1 answer. Okay, and at f of 2.5, we get the positive answer 5.625, and therefore the root lies between these two numbers 2 and 2.5. If these numbers are not given in the example, then find these numbers by using trial and error method. That is, first find the value of fx at 0, and then 1 at, then 2, 3, 4, 5, and if all the signs of this fx at 0, 1, 2, 3, 4, 5 are suppose positive or suppose all are negative, then search these numbers to the left of 0. That is, find the value of f of -1, f of -2, f of -3, and then by using trial and error method, find the two numbers a and b such that f of a and into f of b is less than 0. That is, one is negative and another is positive. Okay, so these numbers are a and b. Right here, instead of this a not a, here b. So these are the a and b. So x1 is what? The formula for false position method formula is what? xr is equal to a f of b minus b f of a divided by f of b minus f of a. So substitute r is equal to 1. So we get the first approximation. Substitute the value of a and f of b and b f of a and all these values, we get this answer. So this is the first approximation. Here the first iteration is completed. Then find the value at this 2.0754 and the value is negative. So at the value a, so this is a is positive. At a is value is negative. At 2 value is negative, and at 2.5 value is positive. And here we have the value is negative, and therefore root lies between this 2.5 and this 2.07. Okay, and so take a as a 2.0754 and b as 2.5. Okay, and then x2 is what? X2 is what? Again, use this a and b and find the f of a and f of b. So f of a is this minus 21115. Okay, and then f of a, substitute again the same formula, a f of b minus b f of a divided by f of b minus f of a. So b is 2.5 because the root lies between 2.0754 and 2.5. Okay, because at 2 the value is what? The value is at 2 the value is negative. Okay, and positive, and at 2.50754 the value is negative, and this 2.5 value is positive. Okay, and then this is x2 2.0907. Again, find the value at this point. At this point the value is what? Is negative. So out of these two, at 2.5 the value is positive, and at this point value is negative, and therefore the root lies between 2.5 and 2.0907. Okay, and then again find x3 by using the formula. That is, out of this 2.5 becomes b, and 2.0907 becomes a, and then x3 is what? A f of b minus b f of a divided by f of b minus f of a. Again, this is the value. Then find the value at 2.0937. Value of the function is negative, and so out of these two, at 2.09 the value is negative, and at 2.5 the value is positive, and therefore the root lies between 2.0937 and 2.5. So this is a, and then this is b, and again use the same formula. That is, substitute x r is equal to 4, x4 is equal to a f of b minus b f of a divided by f of b minus f. So this completes, we have this answer. Okay, and again the value of the function at this point 2.0943 value is negative. So again value at this point is negative, at point this b is positive, and at this point the value is negative, and therefore root lies between 2.0943 and 2.5. So again a is this and b is this, and then again find the value. And so if we observe these successive approximations x4 and x5, and if we find their subtraction, then answer is what? Not something. That is, this answer is correct up to 3 decimal places. And so last sentence is what? Therefore the approximate root of the given equation is what? 2.0944. Okay. So again the same type problem. This is the algebraic equation. X square minus 2x minus 1 is equal to 0. And we are given the root lies between 1 and 2. If this is not given, then find these numbers a and b. So a is 1, b is 3, and then find f of a is obviously negative, and f of b is positive, have opposite signs, and therefore root lies between a and b, 1 and 3. Okay, and then find x1, first iteration. Okay, that is a f of b minus b f of a divided by f of b minus f of a. So all procedure of solving the problems by using Regula-Falsi method or false position method, all procedure is similar to bisection method. Only instead of this a plus b by 2 formula, we use this formula f of A f of B minus B f of A divided by f of B minus f of A. And we have this answer. Again, find the value at 2. We have x1 is 2. So at 2 value is negative. At 1 value is negative. So there is no root line between A, that is 1 and 2. So root line between 3 and 2, 2 and 2. Because at 3 value is positive and at 2 the value is minus negative. Okay. So next, take A is equal to 2 and B is equal to 3. And then again use the formula that x2 is equal to A f of B minus B f of A divided by f of B minus f of A. And therefore we have this answer, 2.333. Okay, and at this value, at this point, the value is negative. So at 2 value is negative, and at 3 value is positive. At 2 value is negative, and at 3 value is positive. And so at 2.33 value is negative, and therefore root line between this 2.33 and this 3. Okay, so A is this and B is this. Okay, and then x3 is again the same formula, A f of B minus B f of A divided by f of B minus f of A. And so answer is 2.4. I can find the value at 2.4 of the function fx. It is negative. So at 2.333, the value is negative. And at the point 3, value is positive. And therefore, and at the point 2.4, the value is negative. So root lies between 2.4 and 3. Because at A, value is negative. At 2.4, value is negative. So there is no root line between 2.333 and 2.4. So the root line between 2.4 and 3. Okay, and therefore x4 is equal to, the next approximation is what? X4 is equal to, substitute R is equal to 4. A f of B minus B f of A divided by B f of B minus f of A. We have this answer. Okay, find this answer by using calculator. And therefore this is the approximation. So here instruction is what? Perform 4 iterations. So after 4 iterations, we have this answer, and it is correct up to 1 decimal place. Okay. The next problem. This is the transcendental equation. Okay. This method is also useful to find the root of a transcendental equation. It's correct up to 3 decimal places. Find this root by false position method. Okay. So fx is this quantity, x e raised to x minus 2. Okay. And then find A and B. So A is 0.5 and B is 1. Instead of this 0.5, we can also take A as 0 and B as 1. And if we find the value at 0.5 and 1, the value at 0.5, the value is negative. At 1, the value is positive, and therefore root lies between 0.5 and 1. Okay. If we find the value at 0, then it is also negative. At 0, we have 0 into e raised to 0 minus 2. That is, at 0, we have the value, at this place, we have the value minus 2. That is negative. And 1 at the value is positive. So, instead of this 0.5, we can also take 0. That is the two numbers 0 and 1. Okay. And then first iteration, x1 is equal to, formula is what? A f of B minus B f of A divided by f of B minus f of A. Okay. So substitute the values of this A and B and f of A and f of B. We have this answer. Okay. And then at this point, what do we have? The answer of the function fx is what? Is negative. So at 0.5 value is negative, and so root does not lie between 0.5 and this 0.8103. And the value, because at the value at 0.8103 the value is negative, and at the 0.2, at the 0.1 the value is positive, and therefore root lies between 0.8103 and 1. And so in next iteration, take A as a 0.8103 and B as a 1. So the next iteration is B as a 1. And then again use the formula x2 is equal to A f of B minus B f of A divided by f of B minus f of A. Okay. And then find the value at, find the sign of this function, or find the value of the function at 0.8479. Okay. And this value is what? Is negative. So at A, the value is negative, and at B, the value is positive, and therefore the root lies between 0.8479 and 1. Okay, because at this point 8479 value is negative, and at the point B, at the point 1 value is positive, and therefore the root lies between 0.8479 and B, that is 1. Okay, and then again take A as a 0.8479 and B is equal to 1, and use this formula, same formula, A f of B minus B f of A divided by f of B minus f of A, we get this answer. And again find the value of the function at 8527. The value is negative. Okay, and therefore the value at 1 is positive, and the value at this 8527 value is negative, and therefore A is what? 0.8520, and B is this. Then you find x4, and this answer, if you compare these two answers, 0.8520 and this is 0.8525. So this answer is correct up to 3 decimal places. And so write last sentence that the approximate root of the given equation is what? 0.8525. Okay. Next problem is again a transcendental equation, and this is the log x with base 10. If it is only a log x, then its base is e. So in mathematics, if the base is not mentioned, then base is e, and if the base is mentioned, then use that base. Okay, that is, if just log x means log x with base e, and log x with base 10 means the base is 10. Okay, so to find the value of log x with base 10, use the knob log on the calculator, and with the base e, if you have to find the log of x with base e, then use the knob ln on calculator. Okay, so fx is this, x log x minus 1.5, 1.2, not 1.5, and then first find two numbers by using trial and error method, such that fx is what? Negative and positive at that number. So data numbers are 2 and 3. At 2, the value of fx is this. So we can find this log 2 with base 10. Use the knob log on the calculator. Okay. So if there is no base, then assume this base is e. Okay. So here, by using calculator, find log 2 by using knob log. Okay, and then we have this again, the log 3 is what? Is this quantity by using calculator, by using knob log, and therefore the root lies between 2 and 3. Okay, and then therefore take A as 2 and B as 3. Okay, and then x1 is what? A f of B minus B f of A divided by f of B minus f of A. Same formula, and then by substituting the values we get this. Then find the value at 2.72012 of the function. So what is the value? Is negative. So at A, at this point the value is negative, and at B, that is at 3, the value is positive, and therefore root lies between 2.7201 and 3. Okay, and therefore x2 is what? Again, A f of B minus B f of A divided by f of B minus f. And okay, there is some problem in recording. Screen sharing is paused. Okay, okay, okay. Then second iteration. Okay, so A and f of A and B are these numbers, and I can use the same formula, find x2. Then find third iteration, x3, x4, and this answer is what? These two answers. If we find subtraction of x3 and x4, then we get the answer. Point not, 4 times not. Okay, that is, this answer is correct up to 4 decimal places. So hence the root of the given equation is what? 2.7406. This is the last answer. Again, this is the problem that find cube root of 18. So suppose cube root of 18 is equal to x, then taking cube of both sides, what we have? 18 is equal to x cube. That is, x cube minus 18 is equal to 0 is the equation. Okay, and then we have to find the value of x. We have to find the value of x means we have to find the value of this. We have to find the root of this equation x2 minus 18 is equal to 0. How we can obtain this equation x2 minus 18? Cube root of 18. Suppose cube root of 18 is equal to x. Then taking cube of both sides, what we have? 18 is equal to x cube, and therefore x cube minus 18 is equal to 0. And then find two numbers such that fx is positive and negative at that two numbers, and that numbers are 2.5 and 2.8. Instead of this 2.5 and 2.8, we can also take 2 and 3. Okay, so at 2.5 value is negative, at 2.5 value is positive, and so a is what? So take a as a 2.5 and b as 2.8. Okay, here is mistake. There is no at this place the value is what? Not 5. It is equal to 2.5. Okay, a is 2.5 and b is 2.8, and then use the formula x1 is equal to a f of b minus b f of a divided by f of b minus f of a. And by using this formula, find the x1 at first iteration, first approximation is 2.6126. Okay, and at this point the value is negative. So at a the value is negative, and so and at 2.8 the value is positive, and therefore root lies between 2.6126 and 2.8. And so next in the next iteration, take a as a 2.6126 and b as 2.8. A as 2.6126 and b as 2.8, and perform the second iteration. Then find the value at this point is again what? Negative, and therefore the root lies between 2.6201 and 2.8, and then find the second third iterations. Okay, and therefore the answer is correct up to 3 decimal places, and therefore write the last sentence that the approximate root of the given equation is what? 2.6206. Similar problem by using second method. This is the another name of this Regula-Falsi method or false position method, is also called second method. Okay, so again fx is this equation x e raised to x minus cos x, or cos x minus x e raised to x. Here is the negative sign, x e raised to x is equal to 0, is equal to cos x. Right here the equal to sign at this place, right? Equal to sign. So what is the equation? X e raised to x is equal to cos x, and that is x e raised to x minus cos x is fx, or cos x minus x e raised to x. And then again find the two numbers. That numbers are what? 0 and 1. At 0 the value is what? 1, and at 1 the value is negative. Okay, so root lies between 0 and 1, and then use the formula a f of b minus b f of a divided by f of b minus a, and then find the sign of fx at this point, 31467. Okay, and the value is positive, and therefore at a the value is positive, at b the value is negative, and therefore root lies between this number 0.31467 and b. Okay, so find the second iteration, perform the second iteration, perform the third iterations, and we get the final answer. Okay, that we get perform fourth iteration, perform fifth iteration, perform sixth iteration. We have this one. Okay, so this answer is what? X6. This answer is correct up to 3 decimal places. 3 decimal places. Here is not 4 decimal places. This is yes, this is 4 decimal places. If you subtract these two numbers, then what we have the answer? Point not 4 times not something. That is, this answer is what? Correct up to 4 decimal places. And therefore, here is the instruction that I'm using the method correct to 4 decimal places. So this answer is what? Correct to 4 decimal places. And therefore, the last sentence is what? The approximate root of the given equation is 0.5177. So these are some problems to solve yourself. So exercise and their answers.